Here's the compounding interest formula. And whenever you have keywords like compounded annually, quarterly, monthly, or semi-annually, or even daily, then we're going to have to use this formula. Okay, so let's take a look at each of these pieces. First of all, A. Well, they never really said what. Oh, here it is. A is the final amount. Okay, so let's say if you borrow, or I'm gonna in a better situation, like let's say that I'm investing. Okay, so today I'm investing $500 and I wait 10 years and my $500 somehow grow to $1 million. Well, $1 million will be A. Okay, the final amount. Okay, so what's next? P is the principal, the amount of money that I invested in the beginning. Okay, the beginning amount. And R is the annual interest rate, and that will be given to you. We just have to read the problem carefully. I don't have to box everything. I'm just going to read it. N is the number of times interest is compounded each year. Now, this is a difficult one. So what I want you to do is I want you to maybe, I don't know, like highlight it, circle it. I want to talk about this, okay? N is the number of times interest is compounded each year. So if they say annually, now I'm going to go ahead and just kind of get started on these 4 problems here. Annually means you are going to compound your interest once a year. So N is equal to 1. We have 4 quarters in a year, right? So if it's quarterly, N equals 4. What about monthly? We have 12 months in a year, so N is 12. And lastly, what about daily? We have 365 days in a year, so your N value will be 365. Another one, I think another common one was weekly, so I'll go ahead and add that, okay? For weekly, how many weeks do we have in a year? 52. So for weekly, N is going to be 12. For semi-annually, because you may see that one too, I don't know, maybe in case. Semi-annually, which means twice a year, so N is going to be 2. Okay, so I think you know what N is. N is how often your interest is going to be compounded per year. So you have to look at how many of these periods you have in a year, and that is how you determine your N value. T is the total time in a year. So let's take a look at Avin's investment here. Avin invests $5,000. So guess what we have? We know P equals 5,000. That's the initial amount she is investing. In an account that earns interest at an annual rate of 3.25%. So I'm going to go ahead and write down that R is 0.0325. Divide that percentage by 100. And they said find the future value of Avin's account after 5 years. So T is equal to 5. And we identified N for all 4 different cases. So let's go ahead and get started, okay? So first of all, annual. The ending amount is going to be, I'm using this formula here, you guys, okay? Let me go ahead and circle the formula. This is the, well, I'll box it. This is the formula we are using. So A equals P of 5,000 times 1 plus R is 0.025. I must divide it by N, okay? N is 1 for annual. And we're raising this to N times Tth power. N is 1, T is 5. So basically, this is just a regular exponential growth function because dividing by 1 and multiplying by 1 on that exponent isn't really going to change anything. But I'm just going to go ahead and type this into the scientific calculator to figure out how much money Avin will have in 5 years if her interest is getting compounded annually. Okay, So I'm going to go ahead and lower my iPad screen a little bit so that you can see what I'm typing in Desmo Scientific Calculator. 5,000 times 1 plus 0. Whoopsie, I think I wrote the wrong thing. Yeah, I did. Let me go ahead and fix this real quick, you guys. I wrote the wrong interest rate on top of this fraction. I need to fix this. 0.0325. I'm so glad I caught it. 0.0325 divided by 1. And then outside the parentheses, I'm multiplying this by, I'm raising this by 1 times 5th power. Do you see what I typed? I wonder if I can zoom in better, but this is as far as I can zoom in. But as you can see, the amount of money is $5,867 and I will say 6 cents. Let's give her 6 cents. So let me write that answer down on my paper or my notes. So when you are doing these interest problems, you must have a scientific calculator, okay? So $5,867 and 0.66 cents. And I rounded up because the number after 0.5 was 6. This was bigger than 5, so I rounded that up to 6 cents instead of 5 cents. All right, next one. What if it is quarterly? All right, hold on. Let me go ahead and set it up over here before I go straight to the calculator. For quarterly, I need to look at the formula. A equals, let me use different color. A equals, well, the amount she's investing it's still 5,000, but inside the parentheses, we will have 1 plus 0.0325 divided by 4 because this case we are doing quarterly. And we're raising this to n times t power. So 4 times 5th power this time. Okay? So let's see. I'm going back to my scientific calculator to evaluate that. I'll lower this a little bit. You know what? I may be able to just change the number here. I'll change the bottom of the fraction to 4. And I'll change this 1, and it was 1 because it was annual, but now we're doing quarterly, I'm going to change that 1 to 4. Oh, let me move my mouse. So the answer is 5,000, let me write this down, $878.38. So this is how you do these compounding interest formula, okay? All right, let me do 2 more with you. Well, this time we have monthly. That means n is 12. So let's keep everything the same, but let's change the n value to 12. A equals 5,000 times 1 plus 0.0325 divided by what? 12. And we raise that to 12 times 5th power. All right, what is that going to be? She's going to have more money than the first 2 cases because the more frequent the compounding is, the faster your money will grow. All right, so I'm going to just go ahead and change the number in the bottom of the fraction to 12. And I'm going to go over here and change that 4 to 12. So if her interests are getting compounded monthly, she's going to end up having $5,880 and let's see, should we give her 94 cents or 95 cents? Because the number after 4 is 9, I'm going to round up to 95 cents. Alrighty, we're doing good. And I'm on my very last one, and I'll just go ahead and do this over here. What if it is daily? The amount is equal to 5,000 times 1 plus 0.0325 divided by what this time? 365. And we're going to raise this to 365 times 5th power. So we're just plugging everything into this formula, right? So I just need to change the bottom of this fraction to what? 365. And then change this number that we're multiplying to 365. So the answer is $5,882 and, well, it says 19, it's 9 cents. I'm sorry, it's 19 cents and 9. So I'll just round this up to 20 cents. So that is it for compounding annually, quarterly, monthly, and daily type of problem. And you can do the same thing if it's weekly. Oh my goodness, I just realized that I have a mistake here. It's not 12. You probably noticed it. Didn't I say 52 and I wrote down 12? We have 52 weeks in a year because 365 days divided by 7 is approximately 52. I'm so glad I caught that mistake. For some crazy reason, I wrote down 12 there. So if you do 365 divided by 7, because there are 7 days in a week, you will get approximately 52. So if you are doing your homework and you see a weekly compounding, please use 52 instead of 48. Okay? So that is it for this video.